Hello and welcome to this webinar in the WIN-Statik Wednesday series. Today we will be talking about frame analysis, and it's an introduction to the software. My name is Fredrik Lagerström and I am the product owner of Prestress. I am also sitting in the technical support for WIN-Statik and FemDesign. Today we will be using the GoToWebinar interface. So if you have any questions, fill them into the questionnaire that you have on screen. And I will have a presentation afterwards, a Q&A session, where I will be answering those, but that will be after this presentation. There is an option for raising a hand, but I will not be looking at that during the presentation. And it is therefore better to ask the question when you get it, and then we can answer it afterwards. This presentation will be recorded and will be made available on the Strusoft YouTube channel, but the Q&A session will not be recorded. So the agenda for today, we will be looking at the initial settings, different program modes, geometry, input of sections and material. We will look at the initial bow imperfections, loads, load cases, load combinations. And after this PowerPoint presentation, I will have a live presentation of the software. And if there is time, then I will have or show some of the calculations, analysis, code check, and presentation of results. Otherwise, that will be in another session after New Year. But I will leave 5 minutes for the Q&A session if there are any questions. The software can be started using the frame analysis button in the start menu for WIN-Statik, and this will be automatically installed if you install any of the WIN-Statik software, and it's also available in the Strusoft installer. We will take a look at the different codes and national annexes, and in the latest version we are only using Eurocode, and we have 3 different parts, and that is the concrete code, the steel code, and the timber code, and that is different licenses. And for each of these concrete, steel, and timber parts, it is subdivided into either using no code, the standard Eurocode, which we will be using today, but there's also available for the British, Danish, Swedish, Finnish, and Norwegian annex. If you are interested in using older versions or older codes, like the old national codes, British Standard, the Danish code, the Swedish old code, and so on, then it is possible to use version 6.3 of frame analysis in order to get or have the possibility to use those. When you have selected the code, then you get introduced to the interface, and one of the key features of frame analysis is the program mode. There are 4 different modes. One is for input geometry, the other is input loads, and then we have the analysis and the design modes. The input of geometry, then there is a menu bar and also toolbars along the side that is unique to the input geometry. It is possible to enter the geometry of the frame that you want to use, either graphical, and it's more of a schematic feature, and it's also possible to use a numerical system that you can enter from the menu bar called geometry here. And that is basically to do the fine adjustments to the schematics that you have drawn up. But it's also possible to define that in the schematics here in the geometry part. The toolbars that we can see here on the left-hand side will light up once we start to enter the geometry, but there are some features that need to be entered first. And that is basically that we need one element in order to enter any boundary conditions or end conditions for the beams. And it's possible to enter the supports afterwards as well. So in the beginning, there will only be a few buttons available here. There are hinges that we can enter once we have at least 2 elements. And they can be either input graphical by right-clicking or by clicking on the element or on the node. Then it behaves a little bit different. If you click on the element or near a node, then that beam end will be transformed into a hinge. But if you click on the node itself, both sides will be hinged. It is also possible to use the hinge command in the menu, and in that case you have to select a member, and here we can see what side is the start joint and the end joint. And if I press here and I select hinge and press change, then this will be turned into a hinge. If we continue with the input of geometry, once we have the frame drawn up, there will be different supports shown here lighting up. So it's possible to define different kinds of supports, like fixed, hinged, rolling support, and fixed rolling supports, and in both X and Y directions. If we take a look at the sections, once you have entered a few elements, or at least one element, it is possible to define different sections on the frame. And we have a standard library that contains the most common concrete, steel, and timber sections. But it's also possible to add your own section. So it's possible to define flange or different kinds of concrete sections, depending on a few things, and that is like templates that we need to define for a flange beam the web and the flange and so on. But it's also possible to enter either numerical or arbitrary cross-sections. Those cannot be designed, and it's only used for analysis parts in order to maybe get the correct stiffnesses. But the standard and the non-standard can be designed. Once we have defined a section list, or the sections that we want to have in the model, then we can apply those sections on different members. And it's possible to also group similar elements. So here I have started to define different members with different sections and also group some of them together. And that means that I only need to define a cross-section, and if I'm changing one cross-section in one group, then all of those cross-sections in that group will also be changed. It is possible to define materials on the cross-sections, and here we have a list of steel shown, but we also have a list of concrete and timber materials, and it's only possible to apply steel material on steel members. And here also the group is very efficient, because if you have one group, then the material will be applied for all of the members in that group. If we take a look at the initial bow imperfections, by default they are included in the first order calculation formulas. And that means that we need to select which elements the initial bow imperfection should be in the second order. So by default, the first order calculations, they are included. Once we have defined our structure, we can move on to loads. And once we do that, there are a few different changes, and one is the menu bar that is changed. There is also a tool in order to select the different load cases that we have in the model, and that is for easy application of the loads. So here I have the load case of dead load. And when I apply the loads that are shown here in the toolbar on the left-hand side, which now has the loads instead of the elements and supports, then I will be applying those loads on that load case. We have different kinds of loads. That is the ordinary load, trapezoidal load, node load, or a point load on an element, point moment, but also movements like the node displacements, temperature, and dead loads. When we are defining the loads, we need some load cases, and those are used for the load combinations. And depending on what kind of load we have, we will have different kinds of psi values. So if I say that I have a permanent load, I will get the psi values for that permanent load, and that is according to each of the national annexes. But I can also define snow load, wind load, and so on, office loads, and the program will see what the national annex is and apply the psi values when we are combining the loads. So in the load cases, we define the name, the type, and for timber structures, we have a duration, but that is only for the K mod values for the timber structures. So if we have a steel or concrete frame, then these values will not apply on the structure. And as I mentioned, we have different loads, but also that it can be applied in different directions. So we have the horizontal load in global X directions, and that's for basically live loads. We have the vertical Y direction that can be applied for dead loads, basically beams. It is possible to define perpendicular to the element, and that's also live loads like wind load. And it is possible for these kinds of loads to define the intensity, but also the starting point of these loads, and that is a distance from each end node of the element that we apply. We can apply an axial load, and that is for the dead load of, for instance, columns. It's also possible to apply projected horizontal loads that might be for wind, but we also have vertical loads, and that is similar to snow loads. Once we have applied the loads, we can see in each different load case, we can see the loads being applied and the direction of the load. Once we have combined or when we have applied the load cases, we can start with the load combinations. And here we define names. Of the load combination. We define a type, and if it's a frequent, quasi-permanent, that window is a little, or that square is a little bit off. It's actually the ultimate limit state, serviceability limit state, if it's a short-term or long-term. Let's see if I can. There we go. Here we have the type, but also it's possible to have a dependency. On the second part here, we have the combination of load cases, and here we define the different partial factors for each load case, and we are using the list of the load cases that is shown here on the far right. And it's possible to just click and select, and if we have the combination of actions also set, so it's a short-term serviceability limit state of the frequent class, then we will get the psi factors correct when we are defining. So if I define 610A or 610B, I might get the psi values according. And now I will show this in the program. So I start with my WIN-Statik launcher and I start with the frame analysis. Here I can define in the input code what code I want to use. So here I had the different national annexes. I will use the standard for today. There is a possible to use wizards here, and what that means is that it's possible to define already predefined frames, and you can just enter the different values if you have a special truss or a special frame that you want to calculate. And it's very useful for roof trusses because it might be a lot of information or a lot of bars in those. But if you want to use like a continuous beam, a column, or grid frame, it is possible to just select one of these and we can input values rather quickly. And we also have the possibility to apply loads on these trusses. This will also be more detailed in a future webinar. But now I will do the basics, and here we have the input geometry, and I will enter geometry here. And what I can do is that I start with either a member or an unsupported joint. The member is the most common of the elements. And I can basically just draw my frame like this. And I want to have something similar to this. And I'm just using the member here all the time. It is possible to delete a member by selecting the delete function, or I can box in a node in order to delete those. I can move a node by clicking on it and dragging, and it will be dragged to that position. I have the possibility to use hinges, and if I select a node, the hinges will be on both sides, and this might be if I have several different members coming into one point, and then I can click on one of the members in order to either add and remove by just selecting. We have the possibility to use an unsupported joint, and that means that I will be able to add a member like this, and there will be an unsupported joint here in or on element 4. And this means that this will not be supported out of the frame, but all black points are braced or supported out of the frame. So here I have a buckling length from 4 to 5, and number 7 is not interfering with that buckling. But if I would have used another or just the normal member, we can see it is divided. And this means that number 4 and number 9 will be braced out of the plane. And for element 4, it is now from element 9 to 5. These are also possible to delete. in the same way. And I have an unsupported joint there as well. Here, when I now have my frame, it is possible to add the supports, either to have them fixed, pinned, or as a hinge, or a rolling support of different kinds and in different directions. If I want to remove a support, I basically just used the joint function and I click on the support, basically saying that I do not have any support. It is also possible to add springs. So here I can enter either just a value, and it will be a spring of kilonewton per meter. And if I set it to 0, it will be removed. It's possible to have different horizontal, vertical, or torsional springs. I can also apply initial bow imperfections, and for that I can select different members. So if I select 1 and 4, I will have the initial bow imperfection added to the columns in this case. I can also use the group function in order to group, but we will define the different groups further on. When I have my frame, I can use the input geometry, and with the preview selected, I have a preview of the element, and I can adjust the positions of my frame. So if that should be in 1, 1, here I have the support shown here. So it's supported in X and Y direction, but it's not fixed. So we leave the motion or the moment free in this case. And if I press change, we can see the in the preview the position of the element. And here I have defined my frame. As for the members, we can also add a section here, and I will press add. And it's apparently already a member, between 1 and 2 here. So I press OK, and I get my new frame. I can input sections here. And I will add basically a few members into the project. So if I go into the steel I section, HEA, we have a list here of the elements that I want to have. So 280, 300, and 400. And here we have the possibility to select, for instance, different timber. So I have different flange beams that I can use, but it's also possible to use non-standard concrete, and I can define my own sections. And I can then, in that case, just add my special name, 500, 800. And with this, I can say OK, and it will be here in the section names. And if I want to add it to the project, I can press add. We also have the numerical, and here we have a different set of different bars already defined with different areas. And it's also possible to add an arbitrary section using a polygon, and here I can define the different places, a name, and since it needs to be a closed polygon, I can also just draw like this and end the polygon in order to complete this section. When I have defined my sections, I will be forwarded into the section list here. And here I can start to define different members. So I can select number 2 here, say HEA 300, press change. I can also select several using the control button and give it a group name. Select one and say change. And if I, in that case, would change one in this group, even the other will be changed. So they are considered together like this. It is also possible to define a direction of them, so you can turn it around its own axis 90 degrees. So now we have defined the geometry and the sections, and we will be applying materials. And since I have the steel sections, I have only the steel materials to select from. And I can select one and press change. And as you see, everyone in group 1 will get the same material. Hinges can either be input using the hinged command, but it's also possible to select a member. So we have member 2 here from 2 to 3, and we can see that it's a hinge in 3, but if I select or unselect, then it will be in the opposite side instead. Here we have the hinges and member types. It's not viable for this kind of frame. It is possible to look at the steel attributes, and here we can basically just say that use the code values for gamma M0 and gamma M1 for these members, and this is the default values. But it's possible to set a user value if you want to just unselect, and for some codes it is possible to use other values, but now I'm using the standard, so it is what it is. If we take a look at the initial bow imperfections, I selected 1 and 4, and that is the value that I will get by default when I select the initial bow imperfections and select, for instance, the columns. If I would have had one member like this, it is possible to apply like a tensile member, basically like a wire for bracing purposes. And this member will only take tension and will not be able to take any compression. But in that case, we need to define it as a tensile force, and it's now activated in element number 5. If we move on to the loads, I will start with showing, here we have the menu that has changed with load cases, loads, load combinations, and the possibility to calculate the frame. In order to calculate, we need some loads. And since I have not defined any load cases, all the loads here are grayed out. So I need a load case. And the load case selector up here on the right-hand side will show which is the active load case. So I will start to add some loads. Dead load, which is a permanent load, and here I have the possibility to define what kind of type of load I have. If I would have had timber structure, I would be able to apply the duration of it here as well. And for some of the types, as we saw here when applying the snow and the wind, the duration class changed automatically. So the program knows what kind of duration that is for the snow and wind, for instance. Once I have the load cases defined, I can select them up here in the selector. And I will be looking at different kinds of loads to apply now. The first is the self-weight, and if I start with the self-weight, I can just click on the different members and it will calculate the dead load and apply it. I will also add some uniform loads, and those will be in the snow load. 14 kilonewton per meter, and I will say it as a projected vertical load and apply it on 2 and 3. I can apply wind loads. And then I use 0.5. And I want to apply it perpendicular to the element. So I can apply it on the structure. On the element 2 and element 3, I want it not as a pressure, but as a suction. So I can select the load by clicking on it and switch it by selecting a minus instead and change it. If I want to apply a node or a joint load, I can do that, and I just enter a value and select the joint that I want to apply it on. But I can also apply a point load on a member, so it's a little bit different because now we need a length as well from the start point. And I want it as a dead load, 10 kilonewton, and I want it to start 4 meters from the starting point. On the other element, I defined it from 3 to 4. So that would mean that the point load would be down here. So instead I will use 1.4 and apply it to get it up here. If you want to define a point moment on an element, it is possible to enter the value and also the length from the starting node. It's possible to define a joint displacement, and this is if you want to take a look at how your structure has or is performing with a set settlement, for instance. Then you just define the distance that you want to move your joint. As for temperature, we define 2 different temperatures, and the program will calculate the difference between one side and the other side and apply the elongation on the warmer side. I also want some deviation loads, and it should be in the X direction. When we are defining the loads like this, it is also possible to use the table in order to stand on a load case. And here it is possible to define the different kinds of loads. And once you have a load defined, it will turn bold, the name here. So it's possible to find any loads. So here I have my 2 point loads. I have my joint loads, the self-weight, which is calculated. And here I have the snow load, wind load, and deviation loads, and so on. And you basically just enter on, let's say, a uniform load, the direction, if you want it to show how it is applied or just the symbolic image. But here it's also possible to see the element, element 2 in this case, or element 3 in the structure. And this is for easier finding purposes of the different loads. Once we have defined all the loads, we start up the load combination. I will define 4 load combinations. So I will short-term serviceability limit states. The type is short. It is possible to add dependencies, and this means that you can apply one load combination, and then after that there will be one load combination dependent on the previous one. So we can inherit deflections, sectional forces, and so on. And this can in the end lead to ultimate limit state where we can define with the regards of what has happened in the earlier stages or earlier dependencies. And this is widely used in pre-stress, for instance. As a combination of actions, I will use a frequent load combination, and I will be able to start adding the different loads. And here we can see what is the main load for this case. And as you can see, we get information that the different in the chosen national annex, it's not possible to use some of these loads, like the snow load and wind load in the quasi-permanent, for instance. So I will only be able to use the dead load and deviation load. I will have 2 ultimate limit states. Here I can have a normal ultimate limit state or an accidental limit state. If it should be dependent on different load combinations. And I want it to be 610A. And here I can also apply the different load cases. And depending on the order that I select them, there will be one that is considered a main, but here in this case, there will be no main. (610B). And here in 610B, we can see the different main load cases, and that is for the temporary load cases. So the one that I select first will be considered main. It is possible to set different consequence classes and snow zones in the calculation settings here. And this value will affect load combinations, different values here. As we can see in this case. It is possible to use the original text where you can see all the factors, or let the program sum it up for you so you get one factor for each load case. Once we have all the load combinations, it is possible to calculate. And in the analysis part, I will be able to show the moments, shear forces and so on. It is possible to display the maximum values as well. Normal forces in the elements, and also different deflections in different load combinations. Here it is possible to look at the different kinds of tables results, and this is for analytical purposes. So this has nothing to do with the code except for the partial factors in the load combinations. So we can see here, but we're not looking at any design of any elements. So here I can see the support reactions in X direction and Y direction for the two supports here. And it's also possible to look in different ultimate limit states, and if we're looking in first order and second order analysis. And it's possible to look in the first order and second order respectively. With the second order is a little bit darker. I can also double click on an element in order to get a graph like this, and if I drag and select, I can see different points and basically say that in this point I have different values. So I'm just dragging and selecting in this graph here, and it's possible to see the moments, shear force, and axial force. And here it's also possible to see how it jumps on this element. I can also see a table of all the forces if I am really keen in the different calculation sections. If I move on to design, I will be able to calculate and look at the code check for the two columns that I have selected here. And here we can see the different load combinations and what is the design value, and it turns out to be 610A in all the combinations. It is possible to also select another section just to give an indication of if it's possible to reduce the size of the member. So here I am, if it's the utilization is above 1, it turns red like this. So I can select that HEA 280 could be okay. What we need to consider is that we have reduced the stiffness and the dead load, and the stiffness is in the calculation here, but the distribution of loads has not been calculated and taken into consideration. So even if it seems okay, then it's possible to change the member and do a recalculation in order to verify that it actually still is okay. And it's possible to look at different materials. So for different elements, I have the different parameters that is used, different section values, and we can see the section class for the steel elements. And here I can switch between the different elements and see the different section classes. And I also have the capacity in order to see for which member what is the capacity in different calculations. And it's the lateral torsional buckling moment capacity that is shown here. That will be one of the part, but it says here design determined by flexural buckling. So we also take a look at what kind of capacity we have for different sections. This was a very quick view, and I will now continue with the questions and answers. If you want to try out the WIN-Statik for yourselves, you can go to our homepage, get a free trial, and it is possible to get a free trial license. Next week, I will be having a shorter webinar about the WIN-Statik software Concrete Corbel in English. And on that note, I will say thank you and goodbye, and see you next week.